Today we're running a demonstration of IQPROMPT. The same task, given to Codex twice. ARM A, the conventional way, ARM B, with IQPROMPT Enhancement. Our developer will take it from here.
Okay, so this is a demonstration part of the IQPROMPT text-to-code construct. And in this, we have a Codex instance on the screen. And basically what it does is two things. It first of all takes the system instructions and the prompt which I gave him. And basically what is being happening in this instance is that it first takes the instructions from the .markdown file, which I have already demonstrated, then take those instructions, feed that into a loop engineering prompt, and then finally strive to achieve a common goal. We have two arms. One will be the conventional way to do the vibe coding or to achieve the goal which we have specified, and the other one will use the IQPROMPT MCP tool to enhance its way to the actual goal. So now let's hit enter and then we will see how it will function. So the IQPROMPT has started to work on, the Codex has started to work on the actual processing. You can see that I have opened the files and it is reading from the same markdown file. So what is IQPROMPT doing in this context? What it does is, first of all, it understands the user intent. For example, if a user want to do something, then they 9 out of 10 times forget to add the specific guardrail for the LLM, so it doesn't hallucinate or cause some silent errors. So what IQPROMPT does, it understands the user intent and then injects those specific guardrails into the user prompt, making it much more enhanced than usual. And also the main difference between both of the instances or arms is basically one is the conventional way and the other one uses IQPROMPT MCP. The rest is the identical process. So about the task, let's recap on that. We have a task in which we have to create a checkout system for an inventory management system, and we can clearly see that the ARM A, which is a conventional way of doing it, is suffering a lot. It is reiterating, re-looping into different iterations, and we can see that ARM A got the real goal into 7 iterations, which is much more than expected. Now the IQPROMPT will go to work. And there you can see that IQPROMPT ARM has done the work in just one iteration. So it cuts down on the iterative part. For example, if you're building loops or if you are just vibe coding your way, using IQPROMPT will be the most beneficial. So we have also made a UI for that, and let's just check how it looks like. And here you can see that it gives us the implementation of various features, like how many iterations it did, what was a rubric, and what were the findings. So that was the implementation.
Every message you send resends the entire conversation. Isn't 7 small charges, growing each time. ARM B ended the thread at the first message. Look at where the time actually goes. The model answered in seconds every round are a developer reading the wrong output and working out how to explain it. Remove the rounds and you remove the waiting. Both arms reached the same result, 8 of 8. The difference is that ARM B was told the boundaries before it started, so it had nowhere to drift. Accepted on the first execution. 1 layer. Every model. IQPROMPT works with any LLM and any agentic tool through MCP. Get yours today at IQPROMPT.ai.